have had some exposure to, but maybe not all of the things I'm going to ask you to do. We're talking about three-dimensional figures in Chapter 11. We're going to be finding volume and surface area, I already told you, and pretty much that's what the entire chapter is about, except this section. This section is going to ask you to look at nets and find cross sections and to be able to identify and name what is the three-dimensional solid. So it's a lot of vocabulary today. Like I said, a lot of vocab. So I'm going to go through that as quickly as I can. So we'll start with what is a face, what is an edge, and what is a vertex. And remember that it's vertices, plural. So a face is going to be the flat surface in your three-dimensional shape. So, like a plane. So if you look at this shape, how many faces does it have? 6, okay? So it has 6 faces. An edge is going to be a line segment where 2 faces meet. So it's the intersection of 2 faces. So how many edges will this shape have? More than 8. 12. It's going to have 4 on the top, which means it's also going to have 4 on the bottom. And then don't forget about the edges that connect up. So we have 1, 2, 3, 4. So it has 12 edges. What do you mean multiply by 2? Oh, I got you. Okay. I don't think it'll work every time. All right, vertex. Vertex or vertices, plural, is the point where 3 or more of your faces come together. So it's going to be these little points here. And how many vertices does this have? 8. So 4 on the top, 4 on the bottom, so 8 vertices. Okay? Vertexes, vertices. So you are going to be asked to be able to identify, name the faces, name the vertices, name the edges. You're going to be asked to identify what kind of shape is it, and more specifically than just these 5 names or 4 names, you're going to have to tell me based on its base, what kind of pyramid is it? What kind of prism is it? Okay? So first, let's just start with the general ideas. Prisms are going to be shapes that do not have circular bases. If they have circular bases, they're going to be called a cylinder. So prism, by definition, is formed by 2 parallel congruent polygonal faces. Remember, polygons are made up of line segments, not curves. So it's going to have a polygonal face. Those faces that are the 2 parallel congruent faces are your bases. And I'm going to emphasize that big time because every year students make a mistake on this shape I'm getting ready to show you. What are the 2 bases of this shape? Triangles. So be really careful. It's the 2 shapes that are congruent and parallel to each other that are your bases. It does not always sit on its base. I could turn it so that now it's sitting on its base, but it's not always in the picture going to sit on its base. So make sure you're finding the 2 shapes that are parallel to each other and that are congruent to each other.
Is it both a base and a face?
Yes. So the bases are the faces that are congruent and parallel. So you're going to have a lot of faces. Faces is in general any polygonal piece that makes up your shape that's a plane. And then the bases are the 2 that are congruent and parallel. Okay, super important. Notice that for a prism, the other faces are going to be parallelograms. Sometimes they'll be rectangles, depending on how the shape is. And we'll look at different pictures where you'll see how sometimes those rectangles turn into parallelograms. But you'll have 2 that are congruent and parallel, and the rest of your faces will be some form of a parallelogram. Maybe a rectangle, maybe a square, maybe a parallelogram. Okay? Cylinders are going to be circular bases, but they are very similar to a prism because they have 2 parallel congruent circles. Okay, we'll talk about what this is for in a little bit. So cylinders are different than prisms because they are not made up of polygons. These are circles, which are not polygons, and this is a curved surface, which is not a polygon. Okay, so cylinder is formed by 2 parallel congruent circular bases. and it has a curved surface that connects those bases. All right, pyramids. Lots of different kinds of pyramids. Yes, ma'am. Correct. So it only has two circular bases. They are technically, I guess, faces, but we would call them bases because there are no other faces. Good question. Yes. All right, pyramids. Again, lots of different shapes you can have for a pyramid. It's formed by a polygonal base. That means not circular. And notice that all of the rest of its faces are going to be what shape? Triangles. So when you're looking at a net, which is going to be a two-dimensional folded, unfolded shape of it, you're looking for key things like that. Do I have triangular pieces that are folding together then, or do I have parallelogram pieces that are folding together? That'll help you decide, do I have a prism or a pyramid? So pyramids are going to have one base, and they're going to have lots of triangular faces, and they come together at a common vertex. And then we have the cones, and cones are going to be just like a pyramid, except that they're going to have a circular base. So a cone is formed by a circular base. It doesn't have any other faces either. It's just a curved surface that connects to the vertex. Okay? So do I have any edges on a cone? No. Do I have any edges on a cylinder? No, because an edge is two faces that connect to form a segment. And I don't have two faces connecting to form segments. I have curved surfaces. Okay? All right. Cube. We are going to change that, and I'm going to require you to know the more precise name for a cube. The most precise name for a cube is a hexahedron. Hexahedron. So write that down. Hexahedron is a cube. What's a cube? It has, and we wouldn't say sides. Now that we're in 3 dimensions, we would say faces. So yes, the cube has 6 square faces, right? They're all congruent, they're all squares. A cube is a prism, but it has all 6 square faces, and we're going to think about it as a hexahedron. Okay, part of your homework and part of the things on the test will be to name correctly what shape you have. So when you're looking at these shapes across the top, notice that you have 2 parallel congruent pieces. That determines what type your base is, and that determines what the name is. So the 2 congruent parallel pieces here are triangles, so it's a triangular prism. The 2, and with a rectangular prism, let's talk about that real quick. That's a square prism. I don't think I have a rectangular prism. All I have are square prisms. So notice these square prisms. How do I know they're square prisms and not rectangular prisms? Okay, because I have distinctly 2 shapes that are squares, right? 2 squares. The rest of them are rectangles. But for every prism, the rest of the faces are going to be some form of a parallelogram. So it could be rectangles, could be squares, could be parallelograms. But because there are distinctly 2 pieces that are parallel, are congruent, and are different, they are squares. These are square pyramids. A rectangular prism, what did I say? I think I said pyramid. Square prisms. Yeah, sorry. Rectangular prisms are going to have rectangles on every side. So that means any 2 rectangles could be your bases because they're all rectangles. Does that make sense? So every pair of rectangles is going to be parallel and congruent. 2 on top, 2 on the front and the back, left and right.
So if they just give us the shape, how do we know what's supposed to be the face and the square on the side's supposed to be the face?
So every prism has rectangles. So you're looking for what are the 2 that are different, that are congruent and parallel. So because this one has 4 rectangles, and this one has 3 rectangles, those are just the faces. It's the 2 shapes that are different. And so because there are 2 distinct squares, we know this is a square prism, not a rectangular prism. If they're all rectangles, then it's just a rectangular prism. And it doesn't matter which 2 you call the rectangles. So if these were rectangles, that you call the bases. These could be the bases. These could be the bases, or these could be the bases. It won't matter. Okay? All right. So rectangular prism, then you're, notice we're jumping up to those regular polygons. Pentagonal prism, hexagonal prism, you could have an octagonal prism. So you're still going to be calculating those areas to find your volumes and surface area. Pyramid's coming to a point, so we've got a triangular pyramid. It's the one that's the base, that's opposite the vertex. Rectangular pyramid, pentagonal pyramid, hexagonal pyramid. Some teachers say pentagonal and hexagonal. I can't do it, but that's how other people pronounce it, so just be aware. It's a pentagonal prism, hexagonal prism. I say hexagonal, pentagonal. Okay. Okay, notice that some of these don't have, across the top, don't have rectangles as their faces. What do they have? What are these? Parallelograms, right? So that's what I said. Sometimes they're not rectangles, they're parallelograms. So what's happened to the shape? It's slanted. So this, and you probably want to add this to your notes, this is considered an oblique. O-B-L-I-Q-U-E. Oblique. It's like diagonal or slanted is what oblique means. So oblique means it's going to be slanted, and if it's not slanted, then we call it a right prism. So oblique means it's slanted, right means that it is perpendicular. The bases would be perpendicular to each other if it's right. Does that make sense? Oblique means that they're going to be slanted, and even though they're, I guess I should have said, the center of one to the center of the other will be perpendicular. Here, the center to center is not perpendicular. Well, no, but yes, we could use that as well. The string, no, because all of mine are right. All of mine are perpendicular to each other. None of them are slanted. So I'll talk about the string in just a second. Okay, so which one of the two on the right here are, which one's oblique?
The first one.
The pentagonal one, okay, that's oblique. And then this one is right. Okay, so everybody understands it could be oblique. And if it's oblique, again, the center to the center will not be perpendicular. If it's right, center to center will form a perpendicular line. Okay, so then down at the bottom, which ones are oblique?
Pentagonal.
Pentagonal and?
Triangular.
Triangular. So it's a little shifted as well, I believe, right? Maybe not. Maybe it's just pentagonal.
Yeah, I think it's.
I think it's just a pentagonal because this one looks like it's perpendicular. Okay. All right, so then some really easy ones that you'll have on the homework. Classify the figure. That means you're telling me what kind of shape is it. I will warn you that, hold on just a second. I will warn you that they don't give you enough markings, so I'll be pretty lenient when I grade your classifications on this lesson, but only for this lesson, because then for the rest of them, I'm going to give you specific markings, okay? So if you look at this, if you say hexahedron, then you're telling me that this piece is congruent to this piece. It doesn't look like it to me. What does it look like? It looks to me more like a square prism, like the top and bottom might be squares, but the front's a rectangle. You are going to have to assume for this lesson only, Javi. I hate that too. So for this lesson, I will accept, okay, if it looks like a square and you think it's a square, I'll accept that it's a square. Or if you think it looks rectangular, I'm going to accept that it's rectangular. So when I grade your homework, I'm going to be pretty lenient on the squares and rectangles because it's going to be more subjective to what you think. So they're going to say that this is a cube, which would be a hexahedron, which is what Edwin said. I'm going to say it does not look like a hexahedron to me. It looks like it's more of a square prism. But on the homework, I would accept either answer because it is subjective. Is that fair?
Yes.
Okay. So I would say square prism. Because to me, that does not look like all of those faces are squares. Okay? All right. Then it says name the vertices, edges, and bases. It did not say how many. It said name them. So this is going to be tedious. So vertices. What are the names of the vertices? Okay, so you're going to name them, not list how many there are. Edges. This is going to be the most tedious one. What are the edges? Make sure you put line segments above them. A, B, BC, CD, AD, AE. So now we're going vertically. AE. Okay, that would probably make me miss some, so I'm gonna go ahead and stay vertical since we did the top. Now let's stay vertical. So AE, DH, CG, and BF. And then now let's go to the bottom. So what are they? FG, EH, HG, and EF, boys. Okay, so that's tedious but easy, right? So should be easy. Now let's list the bases. I want to warn you here. Keep in mind, for the bases, if it's a rectangular prism, then you only need to pick two because any two could be your bases, okay? But if not, if it's something like this, what are my two bases? Circle. So you'll name circle whatever this circle is and circle whatever this circle is. So for this one, what are our two bases if we call it a square prism? A, B, C, D, and E, F, G, H. So it's just saying name the two bases. If you said it was a hexahedron, you could have put any two that were parallel to each other. Don't list all 6 of them. Just pick two bases. No, this has nothing to do with things being congruent at all. You're just naming the shapes. Not if it's a square prism. If it's a square prism, then only the two squares are the bases. The other 4 faces are congruent rectangles, but they're not the bases of your shape. So again, when you're looking at those, if this is my shape, this is definitely not a rectangular prism. It is a square prism, and the only two bases are the squares. But if it's a rectangular prism, then any two, because they're all rectangles, so any two could be considered your bases. Okay? All right, so we're going to go pretty quickly through the next ones together, and I'm not going to list all of them, okay? We're just going to kind of talk about it. I'm not going to be picky about you using the words oblique or right, but I want you to know that there is a difference between oblique and right. So this would be a right what? Pentagonal pyramid. Not a prism. Prisms have 2 parallel bases. Pyramids come to a point. Yes, you have to spell it correctly. Pentagonal pyramid. Pyramids come to a point. Prisms have 2 parallel bases. Okay? You can put right, pentagonal pyramid. I won't count off, though, for right or oblique, but I do want you to understand there's a difference, okay? Okay, so I'm not going to list all of these, but I just want to make sure that you guys understand that the vertices would just be all the letters, A, B, C, D, E, F. The edges, how many edges would we have to list here?
5.
More than 5?
5, 6, 7, 8,
10, okay? So we would list all 10 of those edges. And then how many bases are there? 1. So I am going to go ahead and name the base. What is the name of the base? Okay, A, B, C, D, E. It doesn't matter where you start, but just make sure you're going consecutively around the shape. So you could say D, E, A, B, C. I don't know why you would want to do that, but you could. So here are the answers, and they'll be in the filled-in notes, but I'm going to save us time and not write all those edges out. Is that okay? Okay. Let's go to the next one. What is this shape? A cone. Name the vertices. What is my vertex? Only N, right? M is not a vertex. Okay? Edges. None. Make sure you put none. Don't just leave it off because that means you didn't answer the question.
Isn't there like a N/A?
Sure. Or you could do empty set, 0, whatever. There are none. Whatever you want to do, but just make sure that you tell me something, okay? Don't just leave it off. And then bases. What's our base? Careful, M is a point. It's a circle M. And so I don't know if we've ever talked about how to name a circle. That's what our last chapter is all about, is about circles. To name a circle, you draw a circle with a dot in the middle.
Yeah, there's like something.
Okay.
Just like circle dot.
Okay. And then you have to name it by its center. So what is its center? M. So you put circle M. Okay? And that's what we'll do in chapter 12, is talk all about circles. All right. So there's that one. Moving on. Net. So you may have to on tonight's homework too. Okay, net. So I have lots of nets as well. If you need to play with those, look at them, see what does it look like. I have all different kinds of nets up here, okay? Key things that you look at, though, when you're looking at your net to decide, is it a prism or a pyramid? What is this going to have to be? Triangles means pyramid. So what is this going to have to be? Pyramid. What is this going to have to be? Prism, because it's made up of rectangles or parallelograms. What is this going to have to be? Pyramid. So a net is simply a diagram of a three-dimensional figure that can be folded. Yeah, because I was reading that. So it's a diagram of the surfaces of a three-dimensional figure that can be folded to form it. A net is two-dimensional. Okay, so we're going to take these two-dimensional shapes and make them three-dimensional. All right. Yes. So when you take these and you're trying to play around with them, yeah, you are welcome to play with them. But for time purposes, we're going to have to go quickly, so I don't want us to get too distracted. Okay? But these are up here, and again, you can come in anytime and get in these boxes and play around with these shapes, okay? So as much as you want to. Okay? But notice how they fold up. And then if you need to, the actual shapes, you can come and get markers and mark on them. Okay? Okay, be careful though, they're expensive, and if you are too rough with them, they'll rip apart. Okay? And they're not cheap to buy, so please be careful. Okay, time, we got to come back. Play with them and focus at the same time. So this one says describe the three-dimensional shape. That means classify it, name it. Hexahedron. To me, this does look like they're all squares, right? So I would agree that this is a hexahedron. The book's going to say cube, but you're going to say, that's a baby word. That's right. We are not babies. We are hexahedron all the way. Okay. On this one, I want us to talk about more than just the name of it. So what is this? This is a cone. It is circular. One circular base tells me it's not a cylinder because I would need two circular bases. Has to be a cone. Now let's talk about some things for next lesson and the one after we get back from break. If I look at this cone, when I fold it, who's got a cone? Anybody? No, I didn't pass out a cone. Okay, here's my cone. It's seen better days. It's taped on. So here's a cone. What do you notice that the distance around here will be the same as? The distance around here, what will it be the same as? The circumference of the circle. Do you see how this whole distance folds around the circle? Okay, so when you get a word problem later and they've given you a picture of a net, right now in your notes, you may want to make a note that this distance from here to here is the same as the circumference of the base. So the distance around that is the same as the circumference of your base, the circumference of your circle. Okay? Now, here I'm going to talk about the strings before we go any further. So look at the difference here. I've got a cone and a cylinder, right? In a cone, in a cylinder, there's only one height. And that's what this string is showing you, the height of the cylinder. In a cone, there's going to be two heights. There's going to be the perpendicular height, which the string is showing you right now. Does everybody see the straight down perpendicular from the vertex? Then the string can be pulled over to the side. This is going to be called, in the lesson when we get back from Thanksgiving break, the slant height. Or another way to say it is lateral height. Slant height or lateral height. It is going to be the slanted height on the cone. Do you guys see that? And it's going to be really important. I need your eyes up here right now. What does the slant height and the H height make with the radius? Do you guys see how that's a right triangle? So hold it steady here. We've got H height, we've got radius, and we've got slant height. So in this chapter, when we're on these problems, we may have to use Pythagorean theorem or special right triangles to calculate the H height or to find the slant height. And that's what the string is trying to show you.
Are you gonna have us use like one of the are you gonna have us use one of the chunks over the other
The formulas we're going to learn, some of them will require you to have H height and some of them will require you to have slant height. Lateral height and slant height can be used interchangeably, so I don't care which one you use. That's what you're asking me. Okay. Let me show you on another one real quick. This is where it gets the hardest. Focus your attention right now up here. Okay, so I'm going to go to this shape. What is this shape? It's not a hexahedron. That's a prism. This is a pyramid. What is this? Square pyramid. Base is square, comes to a point, pyramid. Okay, so again, let's talk about those two different heights. What height is this? So that's going to be your H height. So when we're talking formulas later, this is going to be the H height, perpendicular height. What is this height? Okay, so here's where students make mistakes. This is your slant height. You were right. This is slanted as well, right? This is not your slant height. What is this called today? An edge. The edge is not the slant height. Do you see the difference? What do the edge and the slant height and half of this side make? A right triangle. So you might be given the edge and half of the side length, and you have to find the slant height. Or it could be they give you the slant height, and they give you this distance, and you have to find the H height. So there's two situations here where we have a right triangle. Do you see how you can have multiple right triangles? All right, so after Thanksgiving, we're going to have to be careful with our H height versus our slant height versus our edge. Okay, and probably the hardest one is this one. What kind of shape do I have here? Be more specific. What kind of triangular pyramid? Equilateral triangular pyramid. So when we get a shape like this, it's going to be a regular triangle on the bottom. They're all the same. Equilateral triangular pyramid. Again, this is what kind of height? H height. This is slant height. This is edge. And it is not the slant height. What do you notice the slant height is? It would be, but on this triangle, what do you notice that the slant height is? It's just the height of this face, right? So when we're talking about slant height, we're talking about the height of a face. Same over here. The slant height, it is just the height of one of your triangular faces. Do you see how that's just the height of the triangle? Okay, so, and we'll write that down later. I just wanted to make sure that you guys saw that visually today. Okay, so back to my cone, which is where I was headed with this. We agreed this was the circumference of the circle. What do you notice that this distance right here is going to be? The slant height. Do you guys see it? So from the center here to here will be the slant height. The letter they're going to use for slant height is L because it's also lateral height. So if you prefer to call it the lateral height so that L makes more sense, you can. Or slant height. However you want to think about it. Okay, I wanted to point that out on our net. Let's go to the next one. What kind of shape do we have here? Equilateral triangular pyramid. Okay, equilateral triangular pyramid. What do we have here? Cylinder. Let's talk about the cylinder real quick. Who has the cylinder? So on the cylinder, what do you notice that this length of this rectangle is going to be when I fold it up? The circumference of the circle. So this is the same as the circumference of your base. I see it. Okay, what do you notice this distance on the other side of the rectangle is going to be? The height of your cylinder. There's not a slant height for prisms or cylinders, okay? Only if it's a pyramid or a cone comes to a point. So it's just the H height. So this right here would be the height of the cylinder. Are we good? Okay. So just some things I'm trying to point out before we get to those harder problems. Okay, cross section. This is probably the hardest part to visualize. If you're at home and you are struggling with cross section and you have Play-Doh, get some Play-Doh, make the shape, then get a piece of dental floss or something that you can cut that Play-Doh with really easily. And you could get a knife, but dental floss works really well. And then you can slice your Play-Doh to look at it. So a cross section is the intersection of a three-dimensional figure and a plane. So the plane, when I'm talking about your knife is like your plane or your dental floss. Okay, so when we're talking about actually physically doing it, you'll take your three-dimensional shape. So for example, what is this again? Square prism. And if I want to find the cross section, I'm going to take a knife or a dental floss or a plane, and I'm going to slice my shape either horizontally or vertically or diagonally. But I'm going to cut it and I'm going to open it up and look at what two-dimensional shape is there. So your cross section will be the two-dimensional shape that is there when you cut it and look at it. Show you some examples. Okay, go back real quick, sorry. It can be, I should put can be two-dimensional, because this first example is not two-dimensional. Most of the time it's two-dimensional. Okay, so look at this one. So this is basically taking our cone and putting our plane directly on top of it. What's the intersection of my hand or a plane and this cone? What is it? Just the point. Just the point right here. So describe the cross section. Cross section, it would just be a point. It's just a point. Don't be don't make it too hard. Okay? Here is a better picture of what I was trying to say. Most of the time they're going to be two-dimensional, and in this case it is. So now notice that they're cutting this, and I want us to get away from using the words horizontal or vertical, because that will not work for your homework. And here's why. If I say cut it horizontally, but then I turn my shape like this, horizontally is now not the same, right? So you don't want to describe your cross section on how you're cutting it with horizontal or vertical. You want to describe it in reference to your base. So this, if I were describing how I was cutting it, I would say cut it parallel to the base. If I wanted to cut it vertically, I would say cut it perpendicular to the base. And that way I'm describing it in reference to my base. Okay? But this is not asking you that. This is asking you, I'll come back to you, Edwin. This is asking what is the cross section. Describe the cross section. So what is our two-dimensional shape that's formed when we slice this object? Pentagon. So you would just put pentagon. Okay, so if it says describe the cross section, it just wants you to name the two-dimensional, most of the time, shape. Or what is the intersection of the plane and the shape? Okay, what's the cross section here? Hexagon. If it's cut parallel to the base, yes, it will always be the same. If it's cut perpendicular to the base, then no. Or diagonally, as Edwin said. Okay, so that, yes, the next one. So what is our cross section here? A triangle. Very good. Now, it's easy when they give you a picture, right? When they say, describe the cross-section of a plane going through perpendicular to the base of a cone, and there's no picture, And you have to think about visually what does that look like, okay? That's actually what I just described here, which is the triangle, because I'm cutting it perpendicular to the base, okay? But yeah, that makes it harder. All right. So now Edwin's question. What about if it's diagonal? And this should be the last question on your notes, right? Yeah, you do. That's the next question.
Oh, yeah, I did see the picture of that. Oh,
Right?
yeah,
No?
yeah,
You do?
yeah, yeah.
Okay, I just didn't put the picture up. So, a piece, we have 3 left, I'm sorry. A piece of cheese is a prism with an equilateral triangular basis. How can you slice the cheese to make each shape? I cut the cheese. All right, so they do give you a picture, but it may be that you don't have a picture on your homework, so you need to think about it without your picture. You have a triangular based prism, and it says, how should you cut this so that you're making an equilateral triangle? So if you think about a you may have to draw yourself a picture, and this is going to take some practice. Okay, dashes to show that 3 dimension. How should we slice this so that we end up with an equilateral triangle? Remember to use the things like parallel to the base or perpendicular to the base. How should we cut it? Parallel to the base. Okay, so those are the things you're going to use on your homework. Words like parallel to the base, perpendicular to the base. Again, you may not have a picture though, so you may have to draw yourself a picture, and if you don't know how to draw it, then look in the book for shapes that they've drawn and then trace them. Or Google online if you're not sure and see what the picture looks like. Okay, this time we have the same thing, equilateral triangular bases, but we want to cut it so that we get a rectangle. How would we cut an equilateral triangular shape prism? Okay, so if it's like this, how would I describe that? Perpendicular to the base. Okay, use those phrases parallel to the base or perpendicular to the base. Unless it's not parallel or perpendicular and you have to cut it diagonally. So then that's the last one. So they really do grow cube-shaped watermelon in Japan, I think, because it's easy for shipping. So they can grow them, and then it's already ready for the box, shipped in a box. So I didn't know that till this example. Anyway, so I want you guys to read this and see if you can come with how we can cut this. I'm not going to take answers yet. Take some time, think about it, and then we'll check it. You have a question or an answer? Okay.
It's not about salt, it's about difference like full like
Sentences, yes, I do.
Kind of like
By giving it the picture, yeah. But that's still, you're going to have to be able to describe it. So I'm waiting to see, can you come up with the words? Because the harder part's the words. Okay. All right, so let's see what you think. So I gave you this picture. So we're trying to, hey guys, make sure you're with me. Last thing. So you're trying to get a triangular face. So first of all, in the homework, you would have to be able to figure out where to cut to get triangular pieces. So you would have to come up with this on your own. But now that you know this, how am I going to cut it? Describe it to me, and we'll see if what you're saying actually works. So what would I do? How can I cut the watermelon so that I get a triangular face? So cut the corner off like this.
That still makes a triangle. It still makes a triangle. Yeah.
Trying to draw not a triangle, so let's see. So I cut the corner off, right? Okay, so be more specific or descriptive is what I'm trying to get you to do. So tell me again. How would I cut? Okay, so physically tell me, Molly, what do I do? So from the face, Tell me where to start placing my knife to make the cut. Okay, so I could use midpoint. So maybe you could say midpoint of, okay, how many edges?
Three.
So if I found the midpoints of all 3 consecutive edges, because I can't go here, here, and then over here, right?
I mean, yeah, no, that wouldn't make a
That wouldn't make a triangle. So I need midpoints of, okay, 3 consecutive edges that connect at one vertex. So I need to cut diagonally through 3 consecutive midpoints on the edges, diagonally through 3 consecutive midpoints on the edges. What am I missing? The edges that connect at one vertex. So this is what I mean by they can get harder, and you need to be able to be descriptive, okay? Most of them will not be that difficult. Most of them are going to be parallel to the base, perpendicular to the base, okay? All right, you agree this is pretty easy today? Just overview. Hardest part of chapter 11 will be slant height, okay? Hardest part. Everything else will be pretty easy. It'll just be memorizing formulas and using your formulas. You've got your homework. You've got about 7 minutes. Make sure that I get all of the nets, please, put back.